Hello and welcome to this new video. My name is Ahmed Yusri and we are going to talk about the speculative access. Basically, speculative access is an optimization method which is implemented by the new CPU to minimize the memory latency. For example, we have the Cortex M7 which implements this speculative access. While trying to execute some data from the web pipeline or executing some checks or whatever, the CPU predicts that this memory region is required, it will do a kind of a prefetch. So it will get this data, read this data, prepare it here, and if it's really required within the next instruction, then we will save some memory cycles. Okay, this is good. So the guessing game, we cannot predict which memory is internal memory or external memory, which will be accessed from the CPU. So the CPU has its own algorithm, its own, maybe let's say, machine learning algorithm to learn from the previous data which has and try to access the memory which may be in interest for the next execution or for the next instructions. Okay, great. So this is all about the speculative access. It's a prefetch prediction algorithm, and yeah, it looks good. It will save some memory cycles, but why we may need to prevent it. Okay. So now imagine that we have this system. We have a display module connected to our microcontroller unit, which is based on ARM M7, Cortex M7. And this MCU contains a display controller connected to this display class and try to read some frame buffer from an external memory. So we have external memory, we have a display class, we have the MCU which contains a display controller. Okay, and this display module has some timing limitations, so the bandwidth of the bus here is very important. So the first thing which will come to our mind in this design is, what about the other processes which try to access the external memory? Okay, so for that we can prevent the other processes by having a synchronization mechanism. So we will deal with the external RAM as a shared hardware resource or a shared resource, and the display controller as the highest master which have an access to this external memory, and if it tries to access it, then it will lock it and until it finish the execution and then free it again, so the other processes will have an access to it. So this is like a kind of software synchronization, and it could be implemented in an easy way. Okay, so is this everything? No, because we have another let's say a process, but it's not a software process, it's actually a hardware. So we have this MCU has speculative access, which means that we may have the CPU predict that some memory may be required from the external RAM, so it will try to read and prepare it for the next cycles. But however, this is actually not true, and this will limit the bandwidth for the display controller and of course impact our graphics quality. And to prevent this, we need to go to ARM documents, ask them if there is any method to prevent a speculative access from a specific region, because we can of course disable the speculative access, but it's not good because this will impact the execution time. So the second choice is to prevent the speculative access to happen on a specific memory. Like, we don't expect to have speculative access in the external RAM, for example. Then we can configure it, configure a region from the MPU for the external RAM, mark it as never execute never region, and make it as device strongly ordered or device or a strongly ordered memory, and so on. And so basically, yeah, we can use the MPU to optimize our bandwidth and to optimize the graphics quality. Actually, thanks to this document from STM32, it's the application notes of the LCD or the LTDC. This is the display controller. They name it. Just a second. Yeah, the LTDC. So you can go and read this document. It actually contains a lot of useful information and also has some more information about the cacheability and the drawbacks of the caching and how we can prevent the cache coherency problems. Okay, great. Yeah, that's all for today. And please let me know if you have any questions.